Okay, everybody, so this video is primarily about some definitions that we need to know. Okay, so it's just definitions. It will fit into the big picture as we go through all of the lessons for this next test, meaning up through the lesson on Taylor and McLaurin series. But for now, I just have some definitions I need you to get acquainted with. They are the definitions of absolute and conditional convergence. Okay, here they are. So a series converges absolutely if the same series with all the terms made positive converges. Okay, so the series AN converges absolutely if the series absolute value AN converges. What's the difference between these? This series has the same numbers as that one, but in this series, they're all positive. So if there were some negatives in there, that one would be my positive. If that one converges, this one converges absolutely. So this series here converges conditionally if that series by itself converges, but when you make all the terms positive, then it diverges. Okay? So again, what's the difference between this one and that one? These two series have the same numbers in them. None of the numbers are different. It's just in this one, they're all positive. If there was a negative in there, or if some of the terms were negative, they would be made positive. This one converges conditionally if it converges as is, but the absolute value diverges. Okay, so let's just explore that a little bit. So see this series right here. Does it converge absolutely or conditionally, or does it diverge? Okay, now this one here is an alternating series, and that's addressed in another video. But it converges because it's true for this series that the absolute value of any term is more than the next one. If you just look at the terms, that's how it is. They get consecutively smaller, okay? And the limit as n goes to infinity of the absolute value of this formula, which is the limit as n goes to infinity. Well, what would you get if you took the absolute value of this? Wouldn't you just lose the negative 1 to the n? What's the effect of that number? Well, sometimes that's negative 1. So it would just be 1 over n plus 5, which is 0. Now, an alternating series will converge if the terms get consecutively smaller in absolute value and if they go to 0. Check and check. Okay? So this converges. But what about this one? What's that series? That series is this. Okay. Does that series converge? Well, okay. This one is, let's see, what's the first term? 1 over 6 plus 1 over 7 plus 1 over 8, right? That's that one. And all that is here's, I guess here's an easy enough way to think about it. It's like this series if you lost the first 5 terms, okay? So it's like this P series, but you lose the first 5 terms. Well, I mean, if this one diverges, then so is that one. You know, this one like adds up to infinity, I guess you could say. Well, so you lose the first 5 terms. It's not like it's not going to add up to infinity all of a sudden. So this one diverges. That's a P series that diverges, and therefore this one would too. Okay? Okay. Now, what does that mean about this one though? This original series, does it converge absolutely or conditionally? Well, so what was the definition? A series converges conditionally if it converges as it is, but when you take the absolute value of it, and look at that series, then it diverges. Well, that's this one. This series converges the way it is, but if you take the absolute value of it, you get this one, and that one diverges. So about this series, we would say that it converges conditionally. Meaning, if you look at it the way it is, it converges, but then if you make all the terms positive, well, then it doesn't. That's all we're saying with it, okay? All right. So that's our final statement about this one, that it converges conditionally. What about this one? Does this one converge absolutely or conditionally? Well, as it is, this one is like that one, where it is an alternating series, and it does everything it needs to do to converge. Like the terms get consecutively smaller. Just look, get your calculator out and look, they do. They get consecutively smaller, and the terms go to 0. Limit as n goes to infinity of 1 over e to the n is definitely 0. So, okay, that series, the way it is, converges. All right. But what about if you took this series and you made all the terms positive? Then what would happen? Well, if I took this series and I made all the terms positive, it would be 1 over e to the n. And that, well, let's look at it like this. Isn't that like this, if you want to? And this is geometric. R is 1 over e, which is, it's less than 1. I don't know what 1 over e is. Let me get my calculator and tell you. So let's see. 1 over e is about 0.36. About 0.36. So that series right there also converges. So what do we say? If you have a series, okay, that converges, and it also converges if its absolute value converges, okay? So like I got this series, I made all the terms positive, and it converges. That original series, then we say converges absolutely. All right. So my final statement about this one would be that it converges absolutely. Just based on the definition. Take the series, make all the terms positive. That series converges. That means this original one converges absolutely. Okay. What about this one, though? All right, well, so what I notice about this one is that this part right here, this is an alternating series. How do you prove that an alternating series will diverge? Okay, well, that's another lesson, okay, and if you need to, you can look at the video or the lesson on alternating series. But an alternating series will diverge if this limit as n goes to infinity of the absolute value of an is not 0. It's black and white. If this happens, it diverges, okay? All right, so it just is. That's just the way it works. Now, I think then that this will be the case for this series, all right? So let's see. In our case, the limit as n goes to infinity of the absolute value of an, where an is this formula right here. Well, what would you get if, or what would that formula look like if you took the absolute value of it? You'd just lose the -1 to the n, because that number is either 1 or -1. That's the thing in the formula that makes it negative sometimes. So we're just going to get n over 2n plus 1, whose limit is 1/2, and 1/2 is not 0, okay? So this series just diverges, okay? It doesn't converge conditionally. It doesn't converge absolutely. It just diverges. All right, so I gave you one example of each case then. Let's look at one last thing. There's a theorem, and it says if a series converges absolutely, that's one way to say this, meaning if you take a series and you make all its terms positive and it converges, then the original series converges. Okay, so that's a theorem. This is this series, same numbers, but all the terms are positive. All right? Okay, if that series converges, then so does the original. So let's look at an example of how we can think about that. So I ask you this question. Does this series here converge? A third plus a ninth minus 1 over 27 plus 1 over 81 plus 1 over 243 minus 1 over 729 plus. The pattern is that these numbers are powers of 3. 3 to the first power, 3 to the second power, 3 to the third power. That's the pattern as far as the numbers go. The signs have a pattern. Plus, plus, minus, plus, plus, minus. Every third term is negative. Let's see, how would we figure out if this series converges? Is it geometric? No. Well, why not? Well, because, what if you said R was a third? Okay, let's see. Is it true that every term times a third gets you the next one? A third times a third is a ninth. A ninth times a third is not negative 1 over 27. 1 over 27 negative times a third is not positive 1 over 81. So it's not a geometric series. But I think we can use this. Right? What does that series look like if you make all the terms positive? All right, see. Absolute value of an. If I made all the terms positive, it would be a third plus a ninth plus 1 over 27 plus plus plus. If I took this series and made all the terms positive, it would be this one. Okay, that would be geometric. This series, what this series is, if you make all the terms positive, is geometric. R is a third, and it converges. Okay. Now then, what can we say then about the original one? I'm asking, does this series converge or not? Well, okay, so here goes. If the series in absolute value form with all terms positive converges, then the original does. Well, yes, if you take this series and you make all the terms positive, you get a series that converges. Okay? So, this one also converges. That's the thought process. That's what that theorem says, okay? That's how I can tell that this series also converges.